Okay, we're going to keep looking at compounding interest. Today we're going to worry about whether or not we can find the present value, so we're going to rearrange things. But before we get into it, let's get a good look at what compound interest really looks like. So to do that, what I've done is I've got a nice little spreadsheet here. And we can see I've got simple interest happening on this side. So let's look at what happens. So simple interest says if I stick $100 into the account and I'm being charged, say, 5% interest, let's just make that colorful. I'm going to make $5. So by the end of it, I have $105. Simple interest means that that principal stays $100 the whole time. It says, therefore, that my interest is always going to be 5% of that $100. So each year, I'm going to get another $5. So that means that I'm going to be, each year, it's the previous year's plus whatever interest I just made. So if I keep just adding that $5, $5, $5, $5, it's clearly a linear function. The simple interest is going up by $5 a year. Okay. Compound interest. So I'm still starting with the same $100. So that first year I'm still getting $5. But compound interest says that my principal is now going to be equal to last year's final amount. So then when I go to earn my interest on it, it's no longer $5 interest. I'm now making $5.25. So my new amount is last year's amount plus the interest I just earned. So if I keep that pattern going all the way down, what do we see? Now we see you're starting to make more and more and more and more. Okay, so now let's watch what happens when I change my interest rate. Okay, so I did 5%. Well, what if it's 1%? Not a big difference. What if it's 10%? Oh, much bigger difference. Now we're really seeing that exponential curve. What if it's 19.9%, which is what your credit card charge you? Ooh, that's lots. And look at this. Look at that. When you've got such a big interest rate, you go from $100 all the way up to $1,500. That's huge. This is why compounding interest is really great for you when you're investing and not great for you when you're borrowing money. Okay, so let's go back and let's do some problems. Okay, so our compound interest formula is A equals P bracket 1 plus I to the exponent N. And we learned yesterday that little I is really R over big N. And our little n is really T times big N. So we got a lot of stuff happening in here. So you can calculate these pieces off to the side. You can do them all together in one. It doesn't matter. It all means the same thing. It all works out to the same thing. So A, remember, is our final amount. Right? That's your future value. P is your principal, which is your starting amount. Right? That's your present value. Finance likes to have lots of words for things. Your little r, remember, is your interest rate as a decimal. Interest rate as a decimal. So remember, you take your percent and you divide it by 100. T is our time in years. And N is that really cool new word, which is how often it's happening, how often things are compounding. Compounding frequency. And to find that, you will always see compounded something in the question. So compounded means capital N, and then the second word tells you how much. So annually is once. If it's semi-annually, it's 2. If it's quarterly, it's 4. If it's weekly, it's 52, whatever. So you have to find that in the question. Very important. So let's decode our question here. Anton's parents would like to put some money away so that he will have $15,000 to study music professionally in 10 years. They can earn, oh, that should say percent, 6% per annum compounded annually on their investment. How much money do they need to invest now? So as soon as I see that we are compounding, I know this is my formula, so let's list things out. A, P, I equals R over N. little n is t times big N. Okay, and then let's go back and let's reword and let's find out what we've got. So I know, let's see, he will have 15,000. So that's our final amount because that's what we need to have at the end. Blah, blah, blah in 10 years. So there's my time. Okay. 6% is my interest rate. Remember, as a decimal, so that's really 0.6. That compounding annually, we said, is our big N, so that shows up in 2 spots. And how much money do they need to invest now? So that means that my principal is my... Okay, so where are we at? Let's do A equals P bracket 1 plus I to the little n. We always start with our formula. Stick in our numbers. So I've got 15,000 is what I want to end with. I don't know what I want to start with. That's a 1. Plus I, well, that simplifies to 0.6. Little n simplifies to 10. Okay. Order of operations here, people. Order of operations. Simplify what's inside your brackets first. And then you can do your exponents next. So I can calculate that, but you get a whole lot of decimals. So life is just so much easier if you just divide both sides by that number first. 1.06 to the exponent 10, because that's all one number. So I'm just going to divide both sides by that to get it out of my way. And then I throw it into my calculator because now P equals whatever 15,000 divided by that is. So let's see, 15, 1, 2, 3, divided by 1.06 exponent button 10 equals $8,375.92. So therefore, they need to invest $8,375.92 now. Okay, let's do another example. So here, Monica wants to start a business and needs to borrow some money. Her bank will charge her 6.4% per annum compounded quarterly. Monica wants to be able to repay the loan in 5 years, but she doesn't want the amount that she pays back to be more than 20,000. So she's already figured out the maximum she can afford. What is the maximum amount she can borrow, and what's the total interest that she pays? Okay, so we know we are doing this compounded quarterly, right? Very important. So that means that I'm doing compound interest. So A, P, equals R over N. Hang on. Okay, let's look at this one. Monica wants to start a business and needs to borrow some money. Her bank will charge her 6.4% per annum compounded quarterly. She wants to be able to repay the loan in 5 years, but she doesn't want the amount that she pays back to be more than 20,000. She's being smart. She knows what she'll be able to afford to pay back. What is the maximum amount she can borrow, and what's the total interest that she pays? So notice again, we have those very important words, compounded, followed by something. Okay, so compounded means I'm dealing with my compound interest formula, which means, oops, that's I, and little n, which means I'm writing all this down immediately. Okay, now that I've written it down, I can come back and let's go back through and find our answer. So her bank will charge her, oh, there's a percent, so that's my rate. And remember, rates, even though it's in a percent, we want the decimal, so you got to divide that by 100, right? So rate will be 0.064. She compounded quarterly. So quarterly means it happens 4 times a year, right? Quarterly is 4. Monica wants to repay the loan in 5 years. So there's my time. But doesn't want the amount she pays back to be more than this. So this is what she's going to be paying back. So this is at the end. So this is our final amount. How much can she borrow? So that's my P. That's my question mark. Now I have everything. Oh, and then what's the total interest she pays? We're going to have to solve that after. So equation A equals P bracket 1 plus I to the exponent N. So my final amount is the 20,000. We're looking for our initial amount. We've got 1 plus R over N. So you can do it on the side. You can do it in the question. It's totally up to you. And then little n, 5 times 4, well, that's just 20, so let's pop that up there too. Okay, let's simplify what's inside our brackets next. So we've got 1 plus 0.064 divided by 4 equals, well, that's not too bad. Sometimes it's a lot of decimals, to the exponent 20. And I'm treating this all as one number, so I'm going to divide everybody by 1.016 to the 20, 1.016 to the 20. Final answer is 20,000 divided by 1.016 exponent button 20 equals, I get $14,559.81. So if that's our principal, then let's figure out the total interest. So remember, interest is going to be the difference between the final amount and the starting amount. So we know we're going to end at the 20,000, and we are going to borrow the 14,559.81. So if you subtract those, you maybe are paying an interest of $5,440, and that rounds to 19 cents. So therefore, she borrows a max of $14,559.81 and pays $5,440.19 in interest. And there you have it. That is compounding interest rearranging.